Good afternoon, everyone. Thank you for joining this best practice HSM class. So, like Eric said, today we're going to cover only Fusion 360 best practices class. The next month we will be talking about HSM work best practices, and after that, on the next month after the HSM works, we will be covering inventor HSM. So let me just show my screen so you guys can see it. So today I would like to bring your attention to a couple of things about using STL files. So when you have other CAM systems or other softwares, some of those softwares allows you to export STL files. You can use those STL files to calculate rest machining, or you can use those STL files to represent your stock material. For instance, when you're dealing with a casting mold, that casting that came out from the cast, you can sometimes that casting mold comes as an STL. That I have seen that. So you can use that STL to represent your stock. So today I'm going to show you a couple of techniques, a couple of examples, pretty simple examples of how you can use STL and how Fusion 360 deals with STL files. So let me open this file up. So all the files that I'm going to use today are files that are public. They are included in the dashboard of Fusion 360, and some of the files that are not included in the dashboard, that are not included there, I draw that by myself. So if you guys want me to send some of my files, I'm happy to do so. Just send me an email and I can share these files with you. Okay, let me just remove these two toolpaths that I do have here. So this part, let's suppose that I need to machine this part, and I'm going to do this using two setups. So I'm going to clamp this part in a lathe machine, 2-axis lathe, without live tooling. So I can rough out the bulk of material until a certain point. And then I will unclamp this part, move it to a 3-axis CNC milling machine, and start machining all the rest of the material. But I would like to start from the material left behind the lathe operations. So how you can do that? So first, just create the setup. And in the setup, I'm going to define that I'm going to deal with a mill turn machine. And as you know, guys, here is just a matter of specifying how is your stock material, how it looks, if it's a rectangular piece, a bounding box, or if you're dealing with a cylindrical shape. If you're dealing with a cylindrical shape, what will be the stock diameter and what will be the length, okay? So I'm going to add here like just 6.25 inches, 1.5 inches long, and I'm going to add my home position on the front, and I would like to add 20 thousandths on the front so I can face the part off. And then I will cut the part. Let me just make this shorter, so 1.2 inches is fine. I'm sorry, 20 thousandths here, and here is 1.2. All right, so let's make this shorter. So the length of the part is 1.2 inches, so I do have 20 thousandths on the front, and the rest of the material on the end, so I can cut off or unclamp the part. So I'm going to hit OK. So this is the material that I'm going to start with for my turning. So I'm going to face the part off using my face tool. I'm going to rough it out with, I'm going to use the same tool. There is something here that you guys need to check. When you're dealing with a mill turn parts with some cuts that needs to be done after the turning with live tooling, you might need to check this spoon profile. Spoon profile allows the software to kind of spin the part, and when you spin the part, basically the software allows the operation to detect the spoon profile. It is like if you were spinning the part in a spindle, you will be able to detect this profile, okay? So sometimes be aware that if you're dealing with such a part that has some holes, pockets, slots that needs to be done with live tooling, you need to check this, okay? And it doesn't hurt if you check this when you're dealing with a simple part only for lathe machine, for turning, okay? So every time that you deal with a mill turn, in short, you can check this. It doesn't hurt, okay? All right, so I got that done. Finally, I'm going to cut the part up. Do okay. Let me just pick the tool, and there you go. So I do have everything done. So when I simulate this, I'm going to show the stock. If I do play, I'm going to see my face milling operation, my roughing, and my finishing. All right. So now, let's suppose that the lathe machine that I have in my shop does not support live tooling. So I would like to unclamp this part and put it in a vertical 3-axis milling machine and start cutting from this point, okay? So this is a simple example of how you can do to propagate the stock left behind this process. So I'm going to do right mouse click, stock, save stock. When you do this, the software is going to ask you, hey, where do you want to save the stock file? I'm going to save it here I'm going to put it on the desktop actually. Just put it here, Fusion 360, best practices. All right, so this is going to be my stock turning, from turning. Do save. Now, the next operation, the next setup that I'm going to create is for my vertical 3-axis milling machine. So I'm going to do setup, and I'm going to do, hey, this is going to be my model that I want to machine. My stock is going to be from a solid. And where is that solid located? The solid is located at the STL file that I just saved. So which is here on the desktop. I'm sorry. Here it is. Okay, but how we can, I forgot to import the file first. So you need to, prior to creating the setup, you need to bring the file in Fusion 360, into Fusion 360. So let me just do cancel for now. And I'm going to jump into design very quickly. I do have a couple, let me just delete that. I forgot to. All right. So I want to bring the STL file with the stock material left behind the turning operation. So what you need to do is go up here, insert mesh. Insert mesh allows you to import either an object file, OBJ, or an STL file. So I'm going to do that. And I'm going to grab the location where I saved that file, which is here. So you can see here a little preview. Do OK. So just make sure that the units that you're importing with are the same units that you have exported the file. So as you can see here, my bot, when I export the STL file, I did use metric, and my file is in inches. So I need to make sure that the same system is being used for the export and import method, okay? Like so. As you can see, my mesh has kind of the same size as my body, okay? So do okay, because everything is on the spot, is using the same origin. However, if for some reason it's not using the origin that you're looking to place the part at, you can always add some offsets, okay? But I'm going to keep everything as it is because it looks pretty well. Do okay. And this mesh is going to be my stock. All right, so I do have my body and my stock, my model and my stock. So now when I go to manufacture, I just need to create a new setup. My model is going to be that model. My stock will be from a solid where that solid is the STL file that I just imported. So when you do OK, you will see how this is showing the stock that we left behind using the turning operations. Then what I'm going to do is rough out the rest of the material. So in this case, I'm going to use an adaptive clearing. And let me grab the tool. And here I'm going to use rest machining from the stock. In this case, it is optional to use rest machining because the stock material that I don't need to use rest machining because the stock material that I do have in my setup is already the STL file. So it's a good representation of my stock. But if you don't have if you are not importing the STL file to make the stock, to define that as stock material, you can always come here and do from file and specify the location of your STL file. So in my second setup, if I do have my stock as a bonding box, as a rectangular piece of material, but if I want to make the adaptive clearing to detect the material left behind the setup above, you can always save that stock material as an STL file and use it in here. I'm going to show you that workflow. For now, I'm going to use from stock setup and do OK. And actually, let me just show you guys another thing up here so you can see the difference. So I have created two adaptive clearing just to show you the differences of what the rest machining is doing. So the first adaptive clearing, if I do simulate, this is the one that is not using rest machining, okay? So when you look at the toolpath, the tool is removing quite air. It's doing some air machining, you know? It's not removing any material initially, in the first cut, roughly. So when you do the rest machining, like I do have here, okay, this is the second operation. I'm sorry, I did delete the other one. So this is the first one that was doing the air cutting on the outside of the part, and this is the one that is calculating the rest material from the STL defined in the setup, the stock material defined in the setup by the STL. So when you do simulate here, now you will see that the tool is going to approach directly into the part without doing any air cutting, okay? The toolpath is completely different, okay? So this is one of the examples of how you can do rest machining from the stock that is represented by an STL file. So you can let it go up to the end. And there we go. Another thing that I would like to bring your attention is, let's suppose that for some reason I don't want my tool. There is a little slot over here in each of these areas. For some reason I don't want my tool to go there, my adaptive clearing, because I'm going to run another special tool to cut that material. If for some reason you don't want the tool to go into a particular area, you can do several things. The one that I normally use is create a surface over there to cap that region. So in this case, this part is a little bit tricky because, let me just protect this operation. Just because I do know that I need to create a surface, so I need to jump into design and create a surface, I would rather protect the operation prior to adding that surface, because when you add the surface, that surface will not affect anything in my main model. So when you add the surface and you go back to manufacture again, the software will ask you to regenerate the toolpath. And if that toolpath takes a while to regenerate, especially when you deal with REST machining from STL, from previous operations, when you're dealing with REST machining, the simple surface you create, the simple sketch you create, sometimes the software asks you to regenerate the toolpath. And why you will need to regenerate if I have not applied any change to the model? Okay, in order to avoid those unnecessary generates, protect the toolpath. Okay, so that way you can go freely to the design and create your surfaces over here. So that's what I'm going to do. I'm going to use, in this case, I'm going to use a loft, and I'm going to start grabbing the areas that I would like to cap. Okay, like there. I need to add a guide curve here at the bottom. Let me add that guide. And there is still one profile here that I'm missing. There we go. I'm wondering if I do add that. It doesn't look quite good, so I'm going to remove the second rail. I'm going to keep this as it is. Do OK. And then I'm going to cap this area over here. The tool is not diving there anyways, but I will prefer to have a surface right on top of that region. So I just ensure that I don't have any tools going there by accident, you know, because I'm going to drill that with a drill bit. So I'm going to do patch. I'm going to click here. I'm sorry. I need to do patch. Do not disable the chaining. So click there and there and do OK. So I do have two surfaces created. So finally, I'm going to stitch them together. And after we get this done, if you have the surface with a different style, with a different color, that means that the normal vector of the surface needs to be reversed. So if you go to here, reverse, normal, flips the normal vector, the normal direction of the body, this is what this surface, this is why this surface has a different color as my model, because I need to reverse that surface. It is optional, okay? From the standpoint of the CAM, it doesn't hurt if you have the surface with this orientation or with the reverse orientation, okay? It doesn't matter. I'm going to reverse that. So this is the correct color of my surface, okay? But it's optional. From the standpoint of the CAM, it doesn't matter. But just to show you another thing that you can use in Fusion 360. So finally, I'm going to, I think this is not a pattern. This is not a perfect pattern, because if you try to pattern this around, another trick, guys, if you don't find any features of FeatureCAM, I'm looking for the pattern, but I don't know where that is. You can press S down in your keyboard and start typing pattern. And you will see here, circular pattern. If this is one of the features that you normally use in your daily base work, you would like to add this to your shortcuts, okay? You can add that. For instance, if I do a lot of revolves, I can add it to my shortcuts. I'm going to call pattern. I think this is not, let me check. Bodies, click that body, around that axis. Yeah, this is not quite a pattern, so you might need to create all the rest of the surfaces along without using a pattern, because it is not a pattern part, but that's fine. I'm going to, for this training proposed, for this best practice proposed, I'm going to stick with this surface only so you can see it, how the toolpath will avoid that. So when you go to the adaptive clearing, I'm going to do right-click edit, or you can also double-click on it. And every single 3D operation has this model geometry, enable to override the model geometry defined in the job. So this is why this example is pretty good to show you this. So when you do this, and when you click that surface, I'm telling the software that the model defining the job will have a new model. What is that model? It's this model that I'm selecting, this surface. So when you do OK, you can hide the surface. You don't need to keep it shown. You can hide it. So when you do OK, you will see that in this case, the tool is going to try to machine the areas from these slots, but not from this one over here, because the software knows that there is a surface that is capping that feature. Okay, so this is one of the things that you can also use an auxiliary surface. I'm going to show another example that I think is pretty good. But in short, just to show you, this is one of the reasons how you can use STL files. The other way that you can calculate rest material from STL, like I said, in case that you don't have any. Let me create another setup over here, and this is STL mode 2. Try 2. So the other way that you can do an STL calculation for rest machining, in case that you don't have any, let me just do this and do OK. In case that your stock material from the setup is not from an STL file, is not representing the correct stock material, in case that you're dealing with that situation, you can always come here and do, hey, rest machining from STL, from file. This file here is waiting, the software is waiting for an STL selection. In HSM Works and in Inventor HSM, I believe you do have a browse button here to browse the file on the Windows Explorer. In Fusion 360, there is no such that button. I'm not sure why. I have reported that already to the Autodesk development team. But the way that you can add the file over here is by drag and drop over there. Do you see that? Once you drag and drop, the only thing that you need to remove is the file and the 3 dashes. So just do the path of the STL file without the initial file dash dash dash. Without this. Remove that and do OK. So this will do exactly the same thing as we did before. Okay. So this is another way that you can do the STL calculation, for the STL rest machining calculation. So guys, I hope you find this useful for your daily base. Let me just show you another thing for this training proposed, for these best practices. The next thing is how you can deal with like a casting mold, and a mold and a cast. So I do have these two parts, my machine part, which is the part that I'm looking to achieve, and my casting, without the holes, without the pockets. I need to remove a couple of things that are not completed in the casting. So let me create a new file. When you're dealing with a casting and a mold, you need to bring the two files into the same Fusion 360 project file. So I need to save the file first. I do have the file over here. So I'm going to include the machining file, the machined file, the one that I'm looking to achieve. Do OK. And the cast, insert into current design. So I do have these two files. So one does not have the holes. I need to machine the holes. It has a little bit extra material on the bottom, and the other one is the complete file. So you need to make sure that both files are located on the same spot, okay? On the same origin. And again, these files, I draw the files in SolidWorks. So you can import files from either SolidWorks, Inventor, or Solid Edge, or CATIA, from whatever system you're using, whatever CAD system. So do OK. So I do have my machine it and my cast. I'm going to rename this. I cannot rename it because this is the way that I did save this file in SolidWorks is called Mil2Axis and it's linked to this file. So that's why you cannot rename it. But that's fine. I'm okay with that. I'm going to hide the casting for now. And what I'm going to do is go to Manufacture, create a new setup, and do that my module is that module. So the casting module is the machined, the part that I'm looking to achieve without all the holes, with everything. So the part that has all the holes, all the pockets, that has everything made. And the stock will be the part that does not have the holes, the pockets. So it's the casting. That's my stock. So do OK. And here you have it. Just to show you. So you have the stock file, which is a casting. Now I need to make the holes, and I need to remove a little bit of material here at the bottom. So just to show you a little trick over here. Yesterday I had the whole recognition, but it seems that today it ran out. Let me just add more. I'm not sure why my purchase is disabled. I'm sorry, guys. Yesterday, when I was preparing this training, I had all my features, but it seems that today they did run out. I need to do this. All right. There we go. Now I do have those. So this whole recognition feature is part of the manufacturing extension, as well as steep and shallow, the trims. I think the delete passes. I think this trim toolpath is available without extensions. And some of the proving also, some of the inspection surfaces, I think is part of the inspection as well, of the inspection is part of the manufacturing extension. So this hole recognition is the one that I'm going to show you how you can drill all those holes. If you guys normally deal with a lot of holes, you have two ways to make a hole. You can do the regular process and create a template. A template could be like 3 operations, like spot drill, drill, and tap, and then call that template anytime that you deal with the same type of hole. Or you can let the software to calculate, to grab all the tools necessary to drill those holes. So the hole recognition detects every single cylinder in the software. In this case, along this setup, it did find 3 holes, that, and that. It is not highlighting that, but I think it's because my coordinate system is right at the center. But I can fix that. I can correct that. So here on the options, you can tell the software if you want to find holes that are from different orientations. Okay. or if you want to stick with the holes at the setup plane, so only the holes that you can find along my Z. I'm going to tell the software that I want to find all my holes, so this hole, not, so I want to machine this, and that hole, for instance. All right. All the holes that I did find from the bottom, this one, I would like to ignore it. And this one here, I'm going to create a second setup for these holes. So I'm not going to machine those holes at this moment. I'm going to ignore those holes as well. So I'm going to stick with these holes only. So from the tool libraries, I'm going to look at the libraries. Here is where you tell the software where do you want to gather tools from your own library, from your vendor's library, or from the sample libraries. So I do have my inches aluminum, metric aluminum, and my tabs. So once you hit OK, the software is gathering all the tools appropriate to drill those holes. And using this, you can tell what's the action that you want to do for those holes. Spot drill, drill and tap, or only drill and tap without spot drill, or spot drill, drill and bore, or only drill and bore. All right, let's take a look at it, at that process. So if you're dealing with a lot of holes during your daily base work, this is a good tool that you might be looking at. So as you can see here, I'm doing a spot drill over there, another spot drill, another one, drill, 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 a bore, and another bore. Finally here, 2 countersinks and the drills. So these countersinks, I want to machine that. For some reason, the software did not grab that hole. I believe it's because my coordinate system is right at the center. But we can always come back here and tell the software that we want to drill those holes. Even if the software is a through-all hole, as you can see, the software knows that. The software detects that this is a through-all hole, and it will do this drill tip through bottom. You can always come here and do a breakthrough if you want. All right. So then go to the second setup. I'm going to duplicate this setup. Duplicate that. Just reverse, flip the Z axis. I'm going to flip the Z. There we go. Activate that setup. Go to the hole recognition and regenerate. Or I'm sorry, let's edit the hole recognition process. Let's edit that. So here I want to delete all this. I don't want to do these holes on this setup. I only want to make these holes over here. So for these holes, I would like to do drill, so spot drill, drill and tap, or I can do spot drill, drill and countersink holes. So just drill and do the head, the countersink head. If you were dealing with a tap, you can always come here and specify what's the tapping that you're looking to fit on that hole. And do OK. It's gathering all the tools. And I think it's just a matter of waiting a little bit. All these toolpaths that you are looking at here right now will be gone because I told the software to delete those. There we go. And there is one that I forgot to delete, but we can come here and just delete these 2 operations. I might forgot to delete that, to uncheck that in the hole recognition process. So here you are. You have it over here. So finally, the next thing that you can do is face the part up. For the face operation, I'm going to show you another technique of how you can face a part, which is by using an adaptive footing. Adaptive clearing allows you to face the part. So what you need to do is tell the software where the stock is located. You can do it by selecting the stock contour. The stock contour allows you to specify where is the stock located. And then go here and tell that your model bottom is model top, because I want to go up to the top of my model. I want to machine all this material over here. So this is my deeper location of my operation, the top model. Do OK, and there you have it. So if you take a look at the simulate, that's all. So when you simulate everything so you can see it, you will see the I'm sorry, let me just grab the setups. The spot drills. If for some reason you want to use a different spot drill for that, you can always come here and change that and pick another. You can always come into that operation and change the spot drill to whatever spot drill you want. I'm going to show you a trick about that, how you can do a different spot, how you can change the tool of an operation without going into the operation to do that, how you can easily change the tool. So let's suppose that this spot drill and this, I would like to use the tool, the same tool that I have used over, I'm sorry, these three are, yes, exactly. So let's suppose that these three spot drills, I want to use this tool over here. How you can make this tool to be applied over there. So you can do right mouse click, edit, and reselect the tool, or you can just expand this operation, drag this tool, and drop it over there. Do the same over here, and do the same over here. So by doing this, now you're using the same tool, tool number 1. All right. So you don't need to jump inside the operation and change the tool. If there is any other operation where you're using the tool that you want to apply to that particular operation, just drag that tool and everything will be applied. Even here at the bottom, if I want to use my T1, I can do this in between different setups. I thought that in between different setups it will work. It seems that it doesn't work if you're dealing with different setups. Okay, so when you're dealing with different setups, you might need to change that tool manually, okay? So just go over here, edit, and grab the tool number 1. But this might be a good thing that you can use during your daily base work. So this is about using STL and how to play with casting molds. Another thing that I would like to bring your attention is about this example that I do have here. This is a 3D file. This is another example that I would like to show you how you can create a surface to cap those features and don't let the tool to dive into, how you can do another technique for creating surfaces and don't let the tool to go there, because let's suppose that I do have a particular operation that I would like to run there, and when I'm doing my roughing, I don't want my tool to go there and try to machine those, because I'm going to run another operation for that. So I'm going to create a roughing, and I don't want that roughing to go there. So setup, excuse me. Let me just flip the Z. My stock, I'm going to tell that there is no any stock material. All right. So do OK. So let me go and create an adaptive clearing. Just grab here Hold on, guys. Let me grab the tools from this file that I was using already. There is a file that I was using the tools that I meant to use here. So I'm going to open that file so I can have the tools available. When you open a file, you have all the tools available in here. But it seems okay, maybe that file is empty. I forgot to save it. But I'm going to use a tool from my cast and mold. All right, so do okay. This tool might be quite, let me just grab a smaller tool. Let me go into my inches, aluminum, and let me search a bull nose and 1/4 of an inch. Let me do 5/8. Let's hit OK. All right, so as you can see, the tool is going to try to go there. And the tool is quite huge, but if you use a smaller tool, you will see that the tool will go there. 3/8. If I do a 3/8, you will see the tool is going to try to dive there. And like I said, I don't want to, let's suppose that I don't want to touch in that area. I would like to make this roughing without touching there because for some reason there is another special operation that I'm going to run after the adaptive clearing. So if you want to avoid that, in this particular scenario, what I will do is, let me just finish the part first. Before creating I forgot to do that. Let me finish the part first before creating the surface, so you can see what I meant with that surface that I'm about to create. So let me grab a ball. First. I want to create the finishing. So this operation radial is the suitable operation for this particular part because it creates radial passes that points towards a center. The center in this scenario, if you do okay, the center will be the center of your setup. But however, if for some reason you need to specify another different center, you can always come here and tell that your center is in another particular location, okay? Like if I pick that as my center, now the center is over there, the center of your toolpath. Let me go, do not use the center, I'm going to use that center, the center point, and the silhouette, I'm going to use selection. Let's go up to that region. And do OK. Let me just let the tool to go all the way down, all the way up to that face. There we go. Now, like I said, I don't want my adaptive to go there. I don't want my radial to go there either. Or maybe I could let my adaptive to go there, but my radial, I don't want to go there with my radial operation. I would like my radial to avoid that. So if you go to design, again, because I do know that I'm about to create a new surface, I'm going to protect the adaptive because normally the adaptive is the operation that takes more time to regenerate. So let's protect that. Go to design. And here what I'm going to do, I'm going to create, let me just check what are the work planes that I do have available here. Yeah, the origin of this part is a little bit messy. So let me just move the part. I'm sorry, guys. Let me move the part. In Fusion 360, as soon as you start doing some changes, if you're dealing with an imported file that came from another CAD software, before you do the changes, do this, capture design history. That way, every new design feature you start adding, you will be able to go back and change that, okay? If you don't capture design history, you won't be able to change that feature after added. So capture the design history, okay? I'm going to create very quickly here just a sketch over here because I want to grab my center point and I want to move the part. So let me do search, move. I want to move my body. Yeah, that body. And I'm going to do from point to point. There we go. Do OK. Then you can delete the sketch. I'm sorry. Let's hide this. Let's hide the sketch. I can hide it. I don't need to keep it shown. I do have my feature over there. Let me just check something here, guys. All right, I'm going to create a sketch over there. And let me cut the part first. Just cut the part from that plane. I'm sorry. Let me just, I forgot. I need to have a sketch over here. I need to create a sketch that crosses the middle of that. I need to create a sketch over here in the middle of my part. So I'm going to do intersect. I want to intersect my body feature. Okay, this looks good. Hit OK. Find the body. And this is a sketch that I'm looking to have. So this sketch over here. Exactly. So I'm going to draw a vertical line over here, all the way to the center of my part, and another line over here. So this is the portion that I'm looking to create a surface from. So I'm going to trim everything, all the rest. I think I can do windows around and trim that, and start trimming the rest. Trim all this. So this is the surface that this is the area that I would like to use to create my surface. So these two will be for construction. All right, exactly. So when you go up here, revolve surface, you also have a revolve. I'm looking to do a revolve of this profile around that. Let's do new body. Maybe I need to do a new component. Exactly. So this is a surface that I'm looking to use for my finishing operation, so it does not go and dive into those pockets. So when you do OK, you will end up having, as you can see, I'm always I can always come back and change whatever I want in here. Okay. Just because before I start making my changes, I did capture design history. Okay. Otherwise, I won't have. If I don't do that, I will not have this. So this is what I'm looking to use my operation. This is the surface that I'm looking my operation to use. So when you go to manufacture, right click, radial, edit, go to model. And like I said, all the operation has this, all the 3D. You can come up here and do, hey, use that as part of my my model setup. Use that as part of my setup model and do OK. And there you go. So now you're roughing and you're finishing without diving into those areas. The adaptive will do exactly the same thing. So if you go here, model, you can also click that and do OK. So it will do exactly the same thing. So do you see how the tool now goes around that? So this is another thing that I hope you guys find useful, how you can create surfaces to drive your toolpath or don't let the toolpath to go into a particular region. So you don't need to go back. This is an imported file, so I don't need to go back into SolidWorks or whatever other software that I drew this with to create a surface. I can create a surface right inside Fusion 360 if I want. The next thing that I would like to show you, I think I have never shown this in Fusion 360, which is how you can do wrap machining. And I'm going to show you also how you can break. Let's suppose that this file here, I need to machine those pockets, and I need to break that edge using my 4-axis, like using a chamfer tool. I need to break that. How you can use my wrap machining? Let's suppose that I don't have a lathe. How can I use my 4-axis wrap toolpath to go all the way around that cylinder? So just so you are aware, guys, the operation that allows you to do at this moment 4-axis machining are 2D adaptive, 2D pocket, 2D contour, and then inside the collection you do have the flow. I'm sorry, the 4-act, the rotary, this toolpath here. Okay. It's part of the extension, but it's a really nice toolpath, especially if you deal with these more prismatic parts. You can use rotary. And the other toolpath that I think allows you to do 4-axis, which is not part of the extension, it is included in the standard base of Fusion, is flow. Flow, when you do multi-axis, you can limit the multi-axis to be 4-axis if you want. Okay. This is another new thing that they just added to the software. So by default, Flow will try to use the 5th axis. But if you don't have a 5th axis machine, you can limit that operation to be up to 4. So what I want to show you is, let me just create the setup so you can guys see here what I meant to create. I just made a duplication of my setup so I can make my life easier a little bit. I'm going to create a roughing adaptive clearing. Use that tool. So when you're doing wrap machining, you need to check this, wrap toolpath. Click the cylinder that you're looking to wrap around, and then click the geometry that you're looking to project, and do OK. And there you go. So you can do this exactly same workflow for 2D pocket and 2D contour. If I use 2D contour, let's suppose that I want to finish that all the way around. Right mouse click, create derive operation, 2D milling, 2D contour. By doing this derive operation, what you're deriving from is all the selections that you have done, all the settings. Even if there is a setting that it doesn't make sense to keep checked in this, just go here and uncheck that. But all your selections that I did prior to this operation, I can maintain that by using a derive operation, like you see. So I just need to change my tool perhaps to use my finishing tool and do OK. There you go. Finally, I can do a pattern. Report pattern there. 4 times. Just be aware also that when you're doing pattern, when you're doing pattern, the Fusion 360 does not use any resources. It uses a little portion of resources from your CPU because a pattern is so simple that does not require any huge amount of calculations. When you're doing a pattern, is the best way to get toolpath faster because what the software is calculating is this toolpath only. when you do a pattern, it's immediately calculated. There is not too much resources that you need to use in your computer because a pattern is just a duplication of an operation that you have calculated already. Okay. Pattern is the most faster way to create toolpath, especially if you have parts with the same feature around or in a linear pattern and so on. How can I break that edge? Let's suppose that I forgot, I don't have a lathe machine, or even if I do have it, I forgot to break that. Okay, how can I do that? You can do it with a 2D contour. Let me just grab a chamfer tool. Chamfer. Where's my chamfer? Here it is. I'm sorry. For aluminums, I'm going to grab that chamfer. All right. Okay. So when you try to wrap, let me grab around that cylinder. What's the cylinder? What's the contour that you're looking to wrap around? It's that one. You will see this red. What this red means is, hey, I cannot wrap at 360 degrees feature in the same work plane. So when you have a 360 degrees at the same work plane, Fusion 360 is not capable of wrapping that. I'm going to show you a trick. So I'm going to do cancel. What I need to do is break this edge into two sections. Like if you have a pizza, you need to create like a pizza piece in a way that you can select the perimeter of that little piece of face. So let me go to design and create a sketch right up there. And I'm going to do a line like so, and like so. And maybe do like 40 degrees over here and do OK. So this is what I want, what I need to select. So that. So what you need to do then is split the face. So there's a tool here called split face. I want to split that face using that sketch. When you do OK, you will see now I can do two selections. I can select that and I can select the rest. All right, let me just check something. All right, so finally, what I'm going to do is go to my manufacturer, regenerate these two operations, it doesn't hurt. So create a 2D contour, wrap the chamfer tool, go wrap machining, click that cylinder, and here now you can do, hey, I want to wrap. So how you can select only that single portion or the opposite? Only, how you can select that. Hold down Alt keyboard. In your keyboard, hold down Alt. And when you hold down Alt, if you keep it pressed, you are able to select either that or that or that or that. So let me try doing that to see if that works. I'm going to do 20,000 chamfer with 10,000 of tip offset. And the arrow needs to be pointing like that. And here, I don't want this. I'm going to use in computer so you can guys see it better. I'm sorry, flip the arrow. All right, there we go. So just look at that. So now you're able to create some toolpath. But hey, Bruno, how can I continue as a toolpath until I break the rest? Just go here and do tangential extension. Because what you're looking to do in short is extend tangentially this end and this end. So if you do here like 1 inch, let's do 1/2, so you can see it. Now I'm extending 1/2 inch both ways. So in short, if I do now 1 inch, maybe that should be enough. Yeah, that should be enough to break everything. All right. This thing that you're having here is an overlap. All right. Because 0.8 or 1 inch that I have extended is longer than this chord length. So in short, if you don't want to have any overlap, you need to calculate the chord length of this. I'm not sure if there's a way to do chord length 1.374. So you can use that in your extension. You can do 1.374, and you need to divide it by 2 because it's between the two ends. So a half of 1.374 and a half of 1.374 from both extensions. Okay, so you can apply a fraction here, and there you go. You don't have any overlap. All right. Let me round this to 0.7. All right. So finally, if I do simulate, just simulate everything so you can guys see it. So this is my rough finish. I need to flip the direction of my 2D contour. Okay, I need to flip that. But what I would like to take a look at it is that little chamfer that I did using my rotary axis instead of using my lathe machine, mill-turn machine. You know, so you can always come with a chamfer tool and break that edge like so.